To the booth, are we ready? Okay, good morning, everybody. I'm Pete Daly, CEO and publisher at the U.S. Naval Institute. I'd like to welcome all our guests, both in the audience and virtual, here in the Lockheed Martin Auditorium and the Jack C. Taylor Conference Center. This morning's panel is going to probe the role of AI in the battle space, on military platforms, and examine how AI changes the nature of naval warfare. Our moderator is Dr. Gavin Taylor, is Associate Professor at Computer Science at the U.S. Naval Academy. His area of academic specialty is AI and machine learning. He's also co-director of the Naval Academy Center for High Performance in Computing, Education, and Research. He chaired the development of the new data science major here at the Academy, which has just started off with its group for sophomore year. Dr. Taylor will introduce our great panelists in a moment. And before I turn it over, there are some housekeeping items that follow. First, if you haven't already done so, please secure your phone and make sure it's just on stun. And also, this conversation will last approximately 60 minutes, and after that, we'll open the forum to audience questions. For those who are here in person, we've got microphones down at the bottom of each of the big aisles here. I just ask that you actually ask a question quickly, and please tell us your name. And for those who are joining us online today, just please use the chat feature, and we'll get your question up to the moderator. So now, I'd ask our guests to join us on stage. Thank you. And I will turn it over to Dr. Taylor to introduce our super panel. Thank you.
Thank you very much. Thank you very much. Welcome. The growth of AI and machine learning is this generation's moonshot. In the last 10, 15 years, it has changed almost everything that we do, from how we drive, to how I turned off the lights in my room last night, to the national economy, and of course, to how we fight. It's a pleasure to moderate this discussion today on how the military is adapting to this unprecedented rate of change. This morning, we'll hear various perspectives from our excellent panel. Lieutenant General Mike Groen. His final active duty assignment was as director of the Joint Artificial Intelligence Center, where he was instrumental in planning for the Chief Digital and AI Officer within the department. He served multiple assignments as a Marine, on the Joint Staff, and within the intelligence community. He has master's degrees in applied physics and electrical engineering, and he told me he's very proud of his ability to be both a war-fighting Marine and a tech geek at the same time. He's now retired, but he remains passionate about helping the Department of Defense be competitive with our threats. Next to him is Mr. Brett Vaughn. Mr. Vaughn has had a career of over 30 years, most of it in the Pentagon, which spans the intelligence community, the Joint Staff, and the Navy staff. He is currently the Navy's Chief AI Officer. His responsibilities include AI strategy development, strategic communication, international engagement, and AI advocacy across the entire service. I asked Brett for a couple life achievements he's particularly proud of, and he made an interesting parallel. He listed two. He was lead for shaping AI investments inside Navy's Palm 20, and he went skydiving with his daughter on her 18th birthday. He said both were scary as hell, both nearly killed him, and once was quite enough. Finally is Dr. Sam Tangredi, the Leidos Chair of Future Warfare Studies and Professional of National, Naval, and Maritime Strategy at the U.S. Naval War College. Dr. Tangredi has published 6 books on national security issues, including AI at War, of which he is co-editor, and he has held command at sea. He was once portrayed as a short-lived character in an adventure novel, and is now looking for a graphic artist to help produce a comic book featuring an action hero, Alfred Thayer Mahan. Welcome. So I want to start just with, obviously this panel's purpose is to look forward. But I want to start with just laying a basic foundation. So to help us understand where we are today, I first want to ask our panel, what are the ways in which a warfighter would encounter AI in the military now? General Groen?
Yeah, great. Thanks, Gavin. So in the department today, and I know Brett is still rowing, at the oars there inside the department. But inside the department today, we have AI implementation underway, and I think it's really important to understand the context of just like the commercial environment. AI is everywhere. Every industry, production, distribution, investments, retail, I mean, you name it, social, I mean, you name it, AI is driving all of those industries. And it's purposeful. It's for competitive advantage. So inside the Department of Defense, we're a little bit behind perhaps the commercial industry, but we're looking to achieve the same thing, and that is competitive advantage. How do we gain competitive advantage against China, against any of our other opponents, and be able to operate with tempo and with precision? And so this is the real core of what we're trying to build here. Today, that looks like things like AI algorithms that recognize objects and imagery, AI algorithms that detect and recognize patterns of activity, AI algorithms that help the Defense Logistics Agency distribute fuel across a theater, or help manage fleet management and fleet maintenance. Even things like building a watch bill that's sensitive to sailors, skills and experiences, how much time they've already had on watch, how many hours they've had off, like personnel functions. I mean, you think like any function inside the Department of Defense where data and understanding the environment better can allow you to make better decisions or faster decisions or give you competitive advantage. That's where we're trying to implement AI today. At its basic level, I mean, think about a car, right, that you drive today. The car continuously monitors the fuel that's being injected. It continually monitors the air pressure and in the tires and the oil pressure, and it alerts the driver when something happens or needs attention. This is kind of, think about thematically, like how that applies in the military context, where commanders need to be able to drive, right? They're executing operations, but they need something in the background to help them alert to, hey, there's an opportunity here. Hey, there's a problem that you might want to take a look at. Hey, there's a risk being created that probably needs your command's attention. Or hey, you could optimize your operations if you made these slight changes. That's really the state of the art today. Clearly, we're in the exploding, in the knee of the curve here for AI implementation in defense. And when you think about, where this goes, individual drones, drone swarms, you look at what's happening in Ukraine today, where dismounted infantrymen can decimate large armored formations. That happens because of artificial intelligence, the ability to sense, the ability to make sense and act quickly. So all of the artifacts that you see in the combat environment today are indicators to us. And then that's indicators on one hand. On the other hand, when you look at what the digital transformation has done for industry, it's very compelling that, look, we owe our young sailors, our young Marines, our soldiers, our airmen, our space people, I mean, like we owe them that same competitive advantage. And that's what we're trying to achieve today.
Thank you. Mr. Vaughn, do you agree with all that? Do you have anything to add?
No, I do agree, and Mike did a great job. In my job, we paint two big buckets where sailors and Marines are likely to run into AI, and Mike talked about both of them. Either it's AI that fuels some level of autonomy in an unmanned system or a robot or drone, or it's could be a line or two of code that's a decision aid, a tactical decision aid. It could be a logistic decision maker. It could be running on a computer in the Pentagon, on the bridge of a ship, on a SEAL's laptop, or anywhere in between. So I think Mike did a good job at painting that picture on. But in my job, predominantly those two big areas, autonomy and decision aids. So yeah, good job.
I wanted to follow up with you, though. He mentioned we were behind commercial industry in the engagement of AI. Is that something you agree with? Is that something, is that an accurate representation?
You said the notion we're behind industry?
That's right, that we're behind commercial industry.
So I would say that yes, but in what aspect matters? I say we're behind in the application and deployment of AI. A lot of people say we're behind, but in the R&D and the science and technology of AI, we have no peer, and I make that statement globally. Our researchers in the US are the best, and we've been there for decades. A lot of the advancement you see in the commercial and industry sectors are built on the shoulders of basic research done in the government and in the Navy, and there are specific examples of that. Natural language processing is one of them. Where we're challenged now, where we're at risk, with a pacing adversary, is taking all that great work and getting it to the field and the fleet and the force. That's the challenge. That's the key terrain today. So I'll just grab a line that the National Security Commission on AI threw out. They make no bones that we are today in an exploding age of AI deployment. The challenge for us is how do we pull those levers to take all that good work and make it impactful for our sailors and Marines. So that's one of my big challenges, highest priority today.
Okay, thank you. Dr. Tangredi, I suspect you have an interesting take on the strategy of where we are today with AI.
Yeah, I am a strategist who looks and studies at technology, not a technologist who looks at technology. So I have a bit different perspective because I look at any investment in the Department of Defense emerging technology and ask the question right off, how does this deter or defeat the People's Liberation Army, being that the main threat? So my view of AI incorporates the questions of, okay, how much is it going to cost? How much does it improve our processes? What are the vulnerabilities that it brings, and what are the trade-offs, the opportunity costs? So, some of that perspective is a lot different. So what I look at, to go backwards in this question, what Brett was talking about on advancements, the United States is ahead of its competitors on the research and development side, but, China will be the head of AI soon because they're investing a lot more money and they need it for different purpose. They want it for social control, for control of the populace by the Chinese Communist Party. Great incentives to spend a lot of money in it. Chinese companies working on it are forced to give their data and information to the government for their purposes. We cannot force Google to work with the Department of Defense. We need to have other incentives. So although we are ahead in R&D now, we have the best scientists, best technologists and stuff, our competitors have different incentives to approach AI and military applications of AI. China is looking for the ability to control social control. If you've read anything about their social network, they are taking all the data from every individual. You know, have you ever defaulted on a loan? Do you support the party? Are you a party member? Have you ever looked at any information, dissident information? Who do you? And so they need to invest a lot in AI to do that. And then I was going to read a section from the book about that, but if you read their 5-year plan on AI, it talks about military first, and it talks about commercial civilian applications coming out of the military function. Now, and the other thing they want is to have AI systems so that top party members can give almost practically orders down to the tactical level, but they can bypass decision-making level that we value greatly. And on the other hand, Russia is looking for AI as for autonomy primarily because they have to make up for the manpower. And as we're seeing, they're looking at AI in land combat systems where you have autonomous combat vehicles. We're not quite there because we're concerned about keeping the human in the loop and the decision making, but I don't think our competitors are going to be so, our competitors don't look at it in that direction. And so that may force us to more autonomy on that. So
Yeah.
hope that answered it.
Yeah, thank you very much. So that was a really interesting comment about the competition we're in, right? And of course, the possible competitors who are also investing in these and what might happen if we failed to invest in this appropriately. Before we look at this really from the competitive side, though, I want to say specifically, I'd like us to address specifically from the American side, what will this look like if we do this well 15 years from now, right? So what does success look like? How will this change the nature of naval warfare for our military? And Brett, I think this is your job to answer this question. And so I hope to start with you.
Sure. So, if I project forward, a couple things. I think if we're successful, we'll be able to effectively scale AI, which means an AI solution in one sector is easily ported across the enterprise to other folks. So nobody has to reinvent the wheel. There's a lot underneath that statement, though. I think on the face, I would like to see, I think we will see expanded options for the commander. In other words, you take Sam's comment forward, if we do our jobs and increase the sophistication of artificial intelligence as it drives unmanned vehicles in the air, on the sea, underwater. When a commander is given a mission and he looks at the range of options in front of him, he will have a host of unmanned capabilities to pair with his manned force as well, which opens up a vast array, I think, of operational options that he may not have had before with less capable systems. And then, again, for me, war is a series of decisions. When do I go? What forces do I take? Where do I put them? How do I supply them? Where's the adversary? What do I do now? When do I pause? When do I stop? What does victory look like? What does defeat look like? All questions that could, or the answers could be accelerated or more easily arrived at with the aid of a decision aid of the type that artificial intelligence is making today and is poised to make in the future. So what I would hope to see in that is our commanders, our sailors and Marines in operational space making better, faster decisions than the guy on the other side of the table.
And so your office is in the Office of Naval Research, right? So what are some specific areas that you think are worth investing in to help us get to that point that you're thinking about?
Well, I'll even go farther than that. So one of my job is, my office physically is in the Office of Naval Research. Part of my job jar is the Navy Science and Technology portfolio, which obviously includes AI. In that, we're doing a lot of work, obviously, in cyber, electronic warfare. We talked about drones, command and control. But I think you could look across the entire naval task list. The potential is limitless, literally, is infinite. Maneuver, intelligence, fires, command and control, logistics, force protection. I can think of viable AI applications that could be applied against any one of those naval tasks or task areas. But we have to be judicious and careful about where we place our AI bets because our resources are not infinite. They're most definitely finite. In that context, in the Navy, our emphasis today in the application of AI is defined by the CNO's navigation plan. So his strategic vision, right? Today, if you break open the way the Navy staff is going after the navigation plan, and there's an AI objective in that set, the highest priority capability areas that we are focused on in designing, developing, and delivering AI for are how we defend, how we maneuver, how we resupply, and how we shoot fires. There's a lot more to it, but those are, for the CNO and for his strategic vision, that's the top of the priority stack for us in the AI community in leveraging both the work that's being done in the lab, that exists in the lab, is on the cusp of deployment, and we'd like to accelerate.
Okay, thank you. General, do you have anything to add to that?
Yeah, I mean, Brett did a great job. I think the key word that Brett used is scale, right? So I think that today we are successful in integrating the artifacts of digital transformation, technological artifacts. But what we haven't done yet is imagine a transformed military machine. And so a transformed military machine, so you asked about what does success look like? Success looks like overcoming tribalism today, for example. So we're very segmented and tribal. That's just the way we were built as a defense organization. We have to overcome that because in a digitally transformed environment where data is broadly available, algorithms are broadly available, where an Air Force sensor can cue an Army, rocket battalion, like that won't come if we don't imagine that future. So looking beyond technical artifacts, that's not a bad thing, but look beyond that to imagining what that integrated digital enterprise will look like. What are the processes that we need to put in place? How do we integrate those processes? How do we achieve scale so that, this is the magic of software companies and AI companies today, is they can achieve scale. That's why they make so much money. We need to make so much competitive advantage by achieving scale across our enterprises. And that takes a cultural shift just as much as it requires a technological shift. And I think that's a really important thing that maybe we miss, as Dr. Tangredi mentioned, with the Chinese. They are exquisitely organized against this problem. Civil-military fusion with a stated objective to be AI dominant globally by 2030. We need a similar banner that will organize us, and so that we are enormously innovative as a system, but we need that organization now that really gets the drumbeat for competing with a highly organized opponent. The question is, does an innovative actor beat an organized actor? And I think the answer is, if that innovative actor can be just organized enough that you can actually bring your innovation to bear in great ways, in tempo and in precision, then you will actually start to achieve success.
Mm-hmm. So you mentioned this, problem that's well known to all of us who work for the DoD about the siloing and the tribalism that takes place within the DoD. Do you think that you mentioned the ability of different tools to work together, right? An Air Force system helping to target an Army system. Do you think that this will actually help us solve this problem that's been around for decades? Or, I know I'm asking a very difficult question, but how, and does this help?
Absolutely. It is critical to our success as a department, as a warfighting force, and as a pillar of innovation and competition. We have to do this. And so you think about like achieving scale. Think about jointness, for example. So today, jointness, and I was on the joint staff, jointness is a great concept. Jointness is almost like a deconfliction environment, right? Okay, I'm gonna put the Marines here, the Navy's got this piece, the Army's gonna be over here, and there is certainly mutual support that goes across those lines, but largely it's a deconfliction process. Think about what an integrated process looks like from a joint perspective, where, again, that Air Force sensor can now cue, fires elements from the Navy, from the Army, from the Marine Corps, on a small island, outside the South China Sea. Like you won't get that competitive advantage, the ability to like integrate your operations like naturally, right, natively, until you actually get to this integrated digital environment, and then all the things that come with that. AI is one of those things, but the conversation is really about, do we become a digitally transformed military? Do we fight effectively in an integrative way? And can we imagine what that looks like so that we can start putting some chalk lines down, so we can start putting some walls up?
Okay. Yeah, thank you. Dr. Tangredi, I suspect you have some strategy thoughts about where AI is going to take us.
Well, first I want to compliment Brett and the way he's done oversight on Navy programs, because to me, their approach is very much on the practical side, that how do we solve these problems we already have? It's not about transformation. I disagree a lot with the general, because transformation could be bad as well as good. So we need to look at the vulnerabilities. I mean, during the 2000s, early 2000s, you had Secretary of Defense, Secretary of Navy, CNO telling us that the transformational system of the 21st century was littoral combat ship. Where did that get us? So I'm straying a little bit from AI, but the reality is that when you look at scaling up AI or working with AI across the force, I personally don't see a big transformation needed. What I see is us to, like Brett is doing, deal with practical issues to improve the way that we are carrying on these particular tasks, whether it's integrated fires or to communications or whatever. The promise of AI is being able to speed up, taking the big data, be able through the algorithms, and be able to speed up some help to decision makers. It's all about John Boyd's OODA loop, being able to go through that cycle faster and aid the decision makers. But there's, again, vulnerabilities. AI systems are best at rule-based, complete information tasks. There was great heralding of AI system beating the chess master or the Go master. The problem is, in those situations, the rules are known. You have complete information in the sense you know the last move of your opponent. War's not like that. You don't quite know where the information is going. What the information is, your opponent's trying to deceive you. So we have to work on AI that can handle deception. And that's something, if you're, anybody here working on AI, focus on that question, because commercial AI can't handle that. It's not part of the business model. But military applications need to figure out how to literally get machines not to trust themselves, to doubt their own output. Now, it can be done. I'm just saying that the commercial sector has not focused on that. You have DARPA, if you're familiar, Defense Advanced Research Projects Agency, has a counterpart in the intelligence community, IARPA, and they're now looking at the question of deception, of big data, and how the AI systems will manage that. The other thing that working on is AI will be useful for decision makers to help in decisions, but they're also going to help with us being able to control or develop autonomous systems. And there's a lot of issues involved with that. A lot of people get concerned about the development of killer robots, that sort of thing. But if you look at a potential future war against a near-peer competitor, we are not going to have the complete information that we think. The way I envision it is we will have a lack of information. So we need to focus on systems that can deal with the practical tasks even when they don't have complete information. That is a challenge. That's something the commercial world does not. I've talked to CEO in commercial world say, how do you handle deception? And he says, well, it's all a question of having more data. If you have more data, you can find the pattern if somebody's trying to deceive you. But the question is, where's that more data going to come from in a war against a technological near peer? And that is the question. So I don't see transformation as what we should focus on. It's going to happen, perhaps, as we develop the systems. But what we need to do is develop the system for the practical applications now. That is the way, that's my view. And we were talking earlier, we kind of talked, what sort of advice do you give to younger officers who are looking forward to the future? And my advice is, of course, learn how to use the AI systems with man-machine teaming. You definitely need to do that. But you also need to learn how to fight without having information and without a dependence on those systems, because the first target of the potential enemy is our satellites, our communications, our networks. So again, when I look at AI, I said, is it survivable? Can it handle deception? Can it operate with limited information, because it's designed to crunch all that big data? So I compliment what Brent is doing, but I don't view transformation as a necessity.
Yeah, thank you. So we've already addressed the elephant in the room now about how China has been very open about from China's perspective, they say we intend to dominate this space, right? We intend to put huge investment in this. We tend to dominate this, both in the commercial and in the military realms. And so so it's useful to think about vulnerability then, in that context. So we've all now mentioned some very ambitious goals of what we're going to do with AI. Require massive investment into AI. And of course, investment means there's an opportunity cost. There are other things that would also help us fight better that we're not funding if we are investing this heavily into AI. So why is it that, say we lost the AI race, why does this make us more vulnerable than failing to invest in other technologies? Mr. Vaughn, again, I think this is kind of your job, right? It's your job to fight for AI funding, so I'm going to start with you.
Well, again, in my job, we almost never start with AI. As Sam mentioned, we start with a problem or a challenge or a mission or a function where AI can deliver a return that's worth the investment. And that return is usually in some kind of mission, impact, or output. That's how we measure success. So for me, and we have various vehicles and tools to measure how we're doing. Fleet experiments, demonstrations, events like that are some of those where we can watch the needle move. And AI is not the right hammer in every case. That's part of my job too, is helping step through a calculus of problem A, AI type B, hypothesis, results. It's worth it or it's not worth it, right? That's kind of what the calculus looks like. I want to go back to something Mike said, though. For me, AI for the Navy, for the flag mess, for my compatriots in SecNav, we view AI as a competency. That means it's part technology and part human skill sets, critical skill sets that are at the core of AI, whether you're a user or developer. I do see a need for, you call it transformation, I'll call it a shift. And the heaviest lift of that shift is not technology. Technology and the technology investments are pretty straightforward from my perspective. I go back to the silos. I know people don't like the culture word. I'll throw it out there, organization or practice. The way we've been doing business compared to the way you effectively design, develop, and deploy AI today are different. And I'll just give you one aspect that kind of makes the point, I hope. And maybe this is a good opportunity to introduce you all to the 4 horsemen of AI: speed, scale, coherence, and resilience. Number 1 is speed. AI runs on a yardstick of seconds and minutes. If you're betting the farm on an AI capability using a yardstick that is measured in months and years, you're shooting behind the duck. You probably won't even see the duck till it's too late. There is a window of work and investment that will shape, whether or not we're successful, or whether the juice was worth the squeeze, right? That's what I'm looking for. But it's going to take not just chips and software and hardware. The way AI is effectively developed and delivered today is very different. It's a very iterative cycle. It's not linear. It's not a fire and forget technology. You always have to revisit it to make sure it's not being spoiled or poisoned or disintegrated or unhinged. You're always looking at it. Constant is the watchword. Development is constant. Maintenance is constant. Test and evaluation is constant. Verification is constant. We're used to designing, building hardware, things, ships, planes, submarines. They go through T&E, they go out, they operate, they degrade, we bring them back, we fix them, send them back out. AI is different. And it's going to take, I think, on everybody's part, from the deck plate sailor as a user, all the way up to the flags that have to decide where to invest. We have to recalibrate. Doesn't mean we need to change the entire Navy. We just need to change our lens to some degree, and really to the extent where we can fuel the transformation or the shift that I think Mike talked about, because right underneath AI is a digital substrate. And if you don't get that substrate right, you're going to be running in place. I will just tell you today, another part of my job is to watch the inventory of Navy AI-related effort. And we literally have, I'm watching over 1,000 AI-related efforts in the service today. We will not see a return on investment that's satisfactory to go against our high-priority problems until we hit that substrate and get it right. That substrate is data, it's compute, where the compute needs to be, and it's competency. It's training our developers, our acquisition corps, contractors, our requirements writers, requirements holders, everybody to kind of turn the dial and get in a digital software mindset for us to be successful.
Thank you. Sam, I think you had a thought that you wanted to jump in.
I'm going to follow on a little bit of that as far as the choice of where you apply AI. And I've been thinking about example. Also, some people say, well, you don't seem to support AI as much as others. What do we not use it for? And I'll give you an example that I look at, and I hope nobody's got this program up, but surface ship, vibration analysis of surface ship rotating machinery. We can determine based on the vibration of rotating machinery whether it needs to be maintained or something. Someone would say, well, perfect thing for AI to do it. Yes, but we've been doing this for 40 years. We have the software, we know how to do it. Let's apply the AI to something else, because the AI may not improve what we're doing. And when people talk about the AI program improving something, my question is, how much will it improve? Will it improve this decision-making 10% or 50% or 100%? I mean, I think he's looking for those big percentages. There's a lot of things that you would think, because it's involved data and big data, that yes, we could apply to AI for that, but you're going to be spending money on something you may not, in fact, improve. And that's one of the factors when you think about where are we going to apply this. You mentioned something about, in the beginning, about potential opponents in this question, right? Mm-hmm. Okay, the problem in dealing with the potential opponents is this. We have the best Gavin Taylors. We have those people. They are doing good research at the university level, cutting edge. Our opponents don't necessarily have that, but they are looking to pour resources into this AI. I forget the name of someone who was recently working for a key AI scientist who was recently working for Baidu, the Chinese company, came back to Stanford working for startups. And the realization is that AI being used there is going into social control, which is something we don't want. But they're going to pour an investment that we aren't going to pour into because the incentives are different as far as what to achieve. We're looking at solving particular problems, man-machine teaming, and then autonomy. You need AI for the, if you're going to have autonomous systems, you certainly do. And that's what we're looking at. We're not looking at this grand use of AI to monitor society. So again, investments are different. So we're ahead, as I said, with R&D. Because we're looking at the practical problems and we're looking at where does AI help us, where doesn't it? Now, I think that AI will be very needed in autonomous systems. Most uncrewed systems we have are actually controlled by, say, a pilot, just not located in the cockpit, but somewhere else. We're shifting more and more to the autonomous systems because in any conflict against a near-peer competitor, communications and others are going to be spoofed or are going to be taken down. Midshipmen need to continue to study celestial nav because GPS is going to be jammed. So the autonomous systems will probably work in a way that, like submarines did in World War II. You send it out on a mission, it can adjust its mission as appropriate to the conditions, but you probably don't know whether it's going to succeed in that mission until it actually comes back or not comes back. And so that's where you need the AI to be able to drive those. And we're being driven to that. That's, eventually we're going to have to move to that, even though we want to keep the humans in the loop because we won't be having the information like we had for the last 25 years in prosecuting wars in Iraq or Afghanistan where the opponents can't affect our comms or affect our information gathering or affect our networks. And that's what we're going to see. And that's why I think the Navy's looking at autonomy as a big feature for AI.
Mike, we've covered a lot of ground since you've had a chance to weigh in.
Yeah, we have. I would just say this. I mean, I guess I don't. If the criticism is that, well, we're not sure that all the problems will be solved all the time by AI and that's mature today, that's probably true, right? But digital transformation, not AI transformation, digital transformation is a complete shift of your environment to create a culture of measurement where you're actually paying attention to the things that you do so that you can have objective outcomes and you can predict projective outcomes and you can plan on that data environment. And AI is one of the tools. AI is not perfect today. But I will tell you, between 2020 and 2021, private investment in AI doubled, right? Doubled, right? So think about how long we've been doing AI. Think about all the corporations that are actually, using this and using it. Again, spoofing difficult environments. That's used in cybersecurity. It's used in detecting fraud by credit card companies. It's used for analyzing massive markets. For securities trading. I mean, and I'm not suggesting that the department is ready to turn it over to a computer, but you have to see that digital transformation is happening everywhere around us, and it has key competitive advantages. And we can be smart about the way we implement it and the scale that we implement it. Digital transformation doesn't have to come from the best algorithm and work its way down. It comes from a culture of data collection. It comes from a culture of observe, orient, decide, and act, where observing, if NGA can use an algorithm to detect objects and imagery and name them, then that's a digital advantage that we can take advantage of. Maybe in an algorithm, but maybe you get your imagery readout faster, right? So like all of these incremental gains in digitization, in measuring data, and helping to use that data to make good decisions. That's what leads to a digital transformation, right? It's not a thing out there that we're bringing, we're going to dump that on the department. This is how does the department gain competitive advantage in the same way that our opponents do, in the same way that our commercial industry examples do. And yes, is it a dirty, dangerous, uncertain environment? Absolutely. That's what war is all about. And we have to be comfortable with that, right? Being comfortable with that, with all the exigencies of war, is something that military officers, military non-commissioned officers, this is why we swear that oath, right? This is why we have a professional obligation to ensure that our capabilities evolve so that we can gain competitive advantage or at least keep pace with our adversaries. If we're not thinking that way, if we're going to say, well, it's too hard and throw our hands up, then we're not meeting our obligations as service members and as institutions.
Can I follow on that?
Yeah, please.
Yeah, so, when I look at strategic documents, whether it's NDA or National Defense Strategy or what the CNO's asked us to do, I find it hard in my mind to see how we're going to hit those capability targets without a technology like AI. And you're not going to use AI effectively against those objectives without that digital substrate that Mike just talked about. It's absolutely necessary. If you're not doing that, like I said, you're going to be running in place. The beauty of it is, if you do that digital substrate, get that right, you float all the boats, not just AI. Nanotech, biotech, additive manufacturing, all the digital animals, all the things you typically find in the emerging technology, disruptive technology toolbox will benefit, and you'll be more effective at using them. I think one of the key measures for us, and a priority for me, a lot of the times, it's hard to tell how effective a capability or a type of AI is being unless you get out there and you use it and see the results. Get our reps and sets in. The actors on the global stage that are deploying AI en masse are learning lessons, good and bad, but it's all fueling. We have a lot of ammo in the lab, a lot of work in the lab that we can and will be pushing out and watching, but we have to get in the hands of our sailors and our Marines, take a risk above the waterline, and watch and observe, and that's how we'll measure, and that's how we'll go back to the original question of this was worth it, this was not. And the payoff on this, to this degree, that was a good decision.
Yeah.
I just two fingers. I want to mention something that Brett has just mentioned, and that's to find out whether these systems really work, we have to test it at sea. I had the pleasure for a brief period of time working with Admiral Wayne Meyer after he retired and stuff, the father of Aegis system, and perhaps the second greatest program manager in the Navy besides Admiral Rickover. And he would constantly say, you build a little, you test a lot. You build a little, you test a lot. And that's how we need to proceed in these systems. He also said, the world's awash in technology. It's a question of what you can engineer to solve the problems that the Navy needs and what can be useful for the mission. And again, I don't want to seem like I'm contradicting the general, but the Navy's done the digital transformation already. Now we need to improve it. We did that in the developing the Aegis system, in developing these systems at which we are using the major combatants. Now it's a question of how you apply AI to that to improve that. But I think the Navy has been the digital service because of the whole nature of the fact, we operate ships, we're operating equipment, and we've worked on that. The other issue is it depends on how your view of AI depends on how you define it. And if we just define it as systems that could replicate human decision-making, then in that case, the Navy's already got AI. The close-in weapon system detects, tracks, got a fire control solution, and if you had it in auto shoots as if they were a person. Normally we don't operate it that, we usually have an operator. But if you just define AI as some people have, and the original AI scientists did as replicating human decisions, we're already doing that. The question is the second definition, which is how you design systems that can predict future behavior based on the data that they receive. And our learning systems, not just rules systems. And that's going to be the real challenge.
Yeah, thank you. So I want to jump to, right, as a teacher of AI, one of the things that's most interesting to me in the classroom is how at the end of the semester, students say, I had no idea there was this much art in the science. I had no idea there was this much bias in the science. I had no idea there was so much unseen trouble, right? When somebody puts science around numbers, the solution that comes out of the black box seems very trustworthy. And they say, I now trust AI less. I trust machine learning less. And I'm glad I'm an expert in it now so that I can deal with this. So my question is as more and more decisions are offloaded to autonomous systems, and I want to open this up to whoever has the most eager answer to this. As we offload decisions to autonomous systems, how do we hold ourselves responsible for our values rather than just trusting the box? Yeah, Mike.
Yes, I think there's 2 points there. One is like sort of the familiarity with AI and understanding it, bias, errors, et cetera. Think about human decision making. Is there bias? Are there errors? Is it latent? You know, I mean, so you have the same. So it's really important for students of this art to really understand all of the aspects of that. You could argue that bias is the purpose of AI, right? Because you're biasing to understand a thesis like, wow, you know, there's a pattern here and it looks like a pattern I've seen before, and so I think that we're over here. So your data will bias you to that answer, and that's a good thing. But sometimes if you give machine learning algorithms the wrong data, or you give it too much of one type of data. Famous example, you know, a AI algorithm fed pictures of trains to identify a train, and it did. That's a train. That's a train. That's a train. That's a train. Then they showed them a picture of a train track with no train on it, and it said that's a train. Because every picture I've been told is a train has these little rails, right? And so like that kind of bias sneaks into these things. And this is really important for humans to understand that environment. That's really critical. So like understanding the technology is an absolutely imperative here. And implementing it, again, like the Navy's doing, in function by function so that you actually have the functional expertise and the technical expertise together to actually understand how to do this. The worst thing you can do is bring in just technical expertise and say, you know what, let's bring a data scientist in here and he'll lay this all out for us. No, you have to have the warfighting experts who understand the processes that have to be implemented, and then bring the technologists into that space. So that's a really important point, the relationship between functional experts and technical experts. There's another really important point, and we haven't really touched on it yet, but this human-machine teaming, right? So when we talk about autonomy, several people have used well, we're displacing all these decisions, and letting machines make the decisions. Nonsense. What we're doing is building decision support tools that allow human commanders to understand their environment faster and better. That's all this is, right? And so when you start sort of anthropomorphizing the technology, then you're probably in a dangerous place, right? So I think we just have to take a really a steady-eyed look at what is it that we're actually building? Where is the value of AI? And it's recognizing patterns in data. It's extending the human's ability to see into the data environment and be able to draw insights out of that. And then the humans will do what the humans will do with that. Human-machine teaming is a really important point. I mean, we could talk all day about this. But this is, how do you actually define the relationship between the human, whether it's a decision maker or a warehouse clerk or whatever, and the technology, right? And what that technology produces. So there's 3 pieces of that conversation, right? Like, okay, does the human know what to expect? Does the human know how to ask? Does the human know what he wants or she wants? There's the machine. Can the machine actually respond to those requirements? And then there's the interface between the two. And this is a really, it's a huge conversation because it's ripe for error, it's ripe for bias, it's ripe for mistakes. And then, so we have the obligation to continue to ensure that when we talk about human-machine teaming, we understand unintended consequences. We understand unintended responses. We understand execution of a function in a way that we didn't envision before, right? So like all of that, that's science and art of decision-making that has to be applied here. It's not enough to say, well, it's too hard, it's dangerous, I'm just gonna throw my hands up. We can't do that, right? We will not compete effectively with the Chinese if we do.
To follow on. So this is where I think, this is what makes AI unique, for me anyway, in comparison to other technologies. The role of the human. For me, it's a very human-focused endeavor. As Mike said, if you lock a technologist, AI expert in a room alone and ask him to develop code, you failed, okay? Without that warfighter or user or a representative of that community that lives and breathes in that mission or function space, that is step one, an AI expert and the people that are going to be using it. It's so important. At the end, again, for me, the outcome is to augment human decision-making, augment manned operations with unmanned assets. And I wouldn't, I'm gonna contradict myself here in a second and say that I don't like the word offload decisions to autonomous systems. There are some, I'll give you an example in a sec, but for me, the decision chiefly will always be made by the human. In most cases, there are some small cases where it doesn't make sense for matters of time or volume. But by and large, the AI is there to augment and provide a human decision maker a range of options and recommendations so he or she can make a better decision. Now here's the other piece. If you are an unmanned underwater vehicle and you've been given a mission and you encounter a seamount or a rock or an obstacle, I am perfectly happy delegating the decision of whether to go left, right, or around safely around that object to the platform. That just shows you, when we talk about offloading or delegating decisions, there's a sliding scale, right? We have to be cognizant of. That's got to appear in your calculus. That's where the perspective of a human being helped, or the customer, the warfighter, sailor, marine, is important in the design of the code and the capability.
Can I pile on something there, Brett? Because it's not just a good idea. It is the Department of Defense's policy that appropriate levels of human judgment will be applied in every case when you're contemplating the application of force, right? That is the department's policy. So like, we don't have an option to put out an unethical, unobserved, untrained artificial intelligence algorithm or any other algorithm, right? We have constrained ourselves to that human judgment oversight. Nobody else in the world has done that.
Thank you. And so I want to make sure we can get to questions, so I hate to do it, but can you keep it
real
yeah,
quick.
Thank you.
The question is, where in the loop should humans be? And that's a hard question because some people think it's going to be at the decision-making point. But let me give you a quick example, nothing to do with AI. Naval mining, old capture mine in the Cold War. It calculates, counts the number of ships, detect what type of ships, fires off the mine. Now, where was humans in the loop? They were in the loop because they decided where to put that system. That's where the decision is made. So the question is, looking at that, is where in the loop? Because a lot of people perceive, it's not going to, you need a human in the loop midstream of this. But we've already, in the past, created weapons that the humans aren't in the loop midstream. So again, that's one of the questions in handling ethics. Where in the loop does the human have to be? And that's a tough question in a wartime scenario.
Thank you very much. Okay, so now it's time for questions. So we can take virtual questions for those of you who are watching from somewhere else. We can take in-person questions if you don't mind coming up to the microphones. So we have some virtual ones here to get us started. So a lot of you have, or several of you have used the term digital transformation. What do you mean by digital transformation, and how does AI fit into it?
I'll start. So for me, I'll go back to the four horsemen. Speed, and I'm repeating myself on purpose here. I think speed, velocity is one of the dominant factors. I think it's one of the ways that AI will change the nature of warfare, not the essential nature, but its conduct. So how do we strike the right velocity? For me, I look at folks who are doing digital well. Who are the benchmark as I look out there? Who does it well? That has some aspects that we can relate to in the Navy. For me, I like Formula One. It's a very digital enterprise. They move ones and zeros in real time. Like the Navy, every time they put a car on the track, lives are at stake and at risk. So they have to take their job very seriously. They can manufacture parts in minutes. They can manufacture a car in a day or two because they're digital. What does that mean? That means data. The data is good, it's accessible, it's of the right quality, sufficient quality for the task. They have compute where it needs to be. Their cars are censored up to the hilt. And in every race, there's information flowing all the time, if you ever watch, to screens where the teams are watching the cars. And then competency, the people, the drivers, right? For us, for AI in the Navy, data is the fuel, the compute is the engine, and the drivers are sailors and Marines. Without those three things, you're not digital. You're not going to operate or act like it. I like the F1 example. Well, I'm a newfound fan of Formula One. I just like watching it, but it's a great analogy. I have this is the Navy AI patch. At the bottom, there's some Latin. Pressure velocius means foresee faster. That's our motto. It's our mantra. It should be. That's why it's the Navy AI motto. And I think another good one, a very famous naval officer. I have no wish to be connected with a ship that does not sail fast, for I intend to go in harm's way. And that could easily be another mantra for Navy AI. So.
Thank you. I love a prop. I appreciate that.
Yeah.
Happy to advertise.
Yeah.
Mike, you've used this
Well, sure.
term as well.
So here's my prop. So like when I drove here today, I got at navigation that told me the best route to go. It told me that there was traffic ahead. It told me where I could get coffee on the way. It told me what time I was going to arrive. All as a result of digital transformation, right? The data is being collected, the data is being made available, and now a host of users with applications across the entire spectrum can make use of that data environment. And in a civilian capacity, as we live our lives, we use it every day. That competitive advantage that we gain by using that in a military environment is what we seek and what we should seek. That is, like, how can we observe, orient, decide, act quicker, right? How about this? If you have the ability, because you're managing your sensors and those sensors are digitized and they're flowing that data back to you or someplace where you can operate on it, and so that to a degree you're always observing, right? Because you have that live data environment. What's actually happening around me? Not just red, but blue as well, right? So you're observing all the time. You're orienting all the time because you've identified patterns in threat activity. You know what? Every time that fleet does that exercise, they always lead to the left, right? Or whatever. They always lead. They put 3 destroyers out front. Like that. That's a pattern, right? So now you're observing that activity. You're oriented on. There's a context to that activity. Now you can decide. What does that do for your OODA loop? It's kind of like. It's just duh loop, right? So because you're always observing, you're always oriented, you can decide and act really quickly. That's how you win, right? It's generating tempo and operating with precision as a result of that. OODA is one example. Everything else that we do today on our artifacts is the same. It's the same principle.
Yeah, thank you. Sir?
KJ Delamere, OpNav N722, and my night job teaching strategy for the Naval War College. During the Cold War, we tended to look at the Russians as being 27 feet tall and overestimated what a MiG-25 or a Hind could do until we got our hands on one of them. We see a lot of very pessimistic assessments of how far ahead China is. Are we making China in the AI world 27 feet tall like we did with the Russians in the Cold War?
Sam, that sounds like a place for you to start.
There's a difference between how their systems operate and what their ambitions are. Chinese are not today 7 feet tall. However, their ambition is to be. So if we're looking at the future and looking at future capabilities, that's the sort of thing that we need to keep in mind. Again, when you look at investment, and you could tell future capabilities based on investment, who has the investment, who has the incentive to invest a great deal in the system? Well, again, if you're using it for social control as well as military applications, you have a great incentive to investment. They have a wonderful incentive for CEOs of their technology companies to work very close with the military because and they've used this. There's a number of reasons you could have a corruption investigation of practically anything, and if that happens and the trials are actually kept in secret, the penalty is death. So for a CEO of a company, of a technological company, it's really the incentive there to work with the government and produce a military applications is really there. So may not be 10 feet tall today, but we need to look at investment for the future.
Yeah, thank you. Our clock is ticking, so let's view it like a lightning round here, please.
Just to pile on, because I
Please.
think this idea of organization versus innovation is really important, right? The Chinese have the ability, through civil-military fusion, as Dr. Tangredi just described, they practice every day. Health status, neighborhood status, party status. I mean, all of this is measured. Everybody's seen the video, right, of the man walking across the street and being identified across 6 different parameters. And so, like, holy cow, that's impressive. Now, the question is, can they actually turn that machine? There's nobody better at surveilling their people than the Chinese government, right? Nobody. So, can they effectively turn that capability into a warfighting capability? And this is where the balance of innovation comes in, right? So how do we balance organization, and can we innovate that to, can they innovate, and then can we innovate faster? Can we innovate enough and organize ourselves enough so that we actually have the enterprise that can fight effectively against an opponent that is largely organized, not innovative?
Thank you. All right, so we have time for one more question if we're quick. Sir.
Jim Raimondo from the Navy's Digital Transformation Office. Interestingly, I've been flying wing with Brett on a little bit of this. But General, to your point of organization, I'm wondering if you could talk just a little bit about the CDAO and the genesis of that and how that might help with this across the department and the implications for the Navy and Marine Corps specifically. And, we're independent usually and kind of give the Heisman to those joint things in the past. So just one of your thoughts on that.
Yeah, great observation. You know, the only thing that unifies the services is opposition to OSD, right? However, here's the thought process, right? So we had organizations focused on particular technologies, the JAIC, for example, focused on AI. I think the insight was, hey, you know what? We have to deal with this larger digital transformation. AI doesn't work unless you have a data environment, unless you have a platform environment, unless you have processes that you can digitize. So I think the thought process behind the CDAO is let's get all of that into one place where we can actually manage it like cohesively at the top. That still leaves us, though, so if you have a highly organized OSD agenda, still leaves you with our core culture of separate services, largely following, building domain-specific hardware through a hardware process in an environment where software now becomes the primary capability driver, and software evolves continuously, right? So how do you take a tribal segmented hardware environment and operate it as an integrated software environment? This is our core challenge.
Thank you very much.
Okay. Well, first, I would like to extend our thanks from the Naval Institute to Dr. Taylor, Dr. Tangredi, Mr. Brett Vaughn, and Lieutenant General Mike Groen for a superb discussion. I'll be honest, going in as a liberal arts guy, economics major, I wasn't so sure about this AI thing for an hour and 10 minutes. You guys have made it fly by. And it's very clear that we need to do more in this area, and that the amount of emphasis on the man in the loop, the woman in the loop, and the skepticism of both the people and the machines with respect to this has really come through loud and clear. It's a tremendous point. So I'd like to thank our panelists and our moderator, and let's give them all a big hand. I want to mention that afterwards, one of our panelists, Dr. Sam Tangredi, is also a Naval Institute Press author, and he'll be available to sign his book, AI at War, and outside for people who are interested, and we thank you, Sam. And for today, as a gift to our panelists, I'd like to do this Naval Institute Press book as a gift, War Transformed, The Future of the 21st Century, Great Power, Competition, and Conflict by Mick Ryan, one of our more popular books. So I'm going to give each one this book, and let's give each one more hand. Thank you very much.